Hey guys, and welcome to this video on big O notation. So here we want to prove that 4 to the power of n is big O of 8 to the power of n. So let's get started by first looking at the definition for big O. So here we have the definition, and it states that a function that we call f of n is or belongs to big O of g of n if and only if there exists positive constants that we call c and k, such that the absolute value of the function f of n grows less than or equal to some constant that we call c times the absolute value of some function g of n for all values of n that's greater than or equal to some positive constant k. All right, so let's go ahead and get started. First thing we want to do is identify our function f of n. So f of n in this case is equal to 4 to the power of n, and then we want to identify our function g of n. So g of n is 8 to the power of n. And now all we need to do is basically either choose two values c and k that would make that statement true, that f of n grows less than or equal to some constant times g of n for all values of n greater than or equal to k. Or we can assume some value for k, or choose a value for k, and then derive a value for our constant c. And so that's what we're going to do. So first thing we're going to do is rewrite our equation. All right, so we have the absolute value of f of n grows less than or equal to some constant c times the absolute value of g of n for all values of n greater than or equal to k. All right, now, again, what we're going to do is derive that constant value c here. So we're going to assume some value for our constant k. All right, so I'm just going to erase those markings. Now what we're going to do is we're going to assume that k equals 1. Okay? So if k equals 1, then we can now rewrite our equation by substituting in for f of n 4 to the power of n, and substituting in for g of n 8 to the power of n, and substituting in for k 1. So let's rewrite our equation now. So we get 4 to the power of n is less than or equal to some constant times 8 to the power of n for all values of n greater than or equal to 1. And now all we need to do is find that c value that will make this statement true, or this equation true. All right, so what I can do is I can divide both sides by 8 to the power of n. And what we get is 4 to the power of n divided by 8 to the power of n is less than or equal to c times 8 to the power of n divided by 8 to the power of n for all values of n greater than or equal to 1. All right, so what does this equal? Well, it just equals 1 over 2 to the power of n is less than or equal to some constant value c for all values of n greater than or equal to 1. And I could have chose any value for k. I could have chose k to equal 2, 3, 4, or 5. But in this case, we chose k to be equal to 1. And what we'll realize here is that our left-hand side of the equation, which is 1 over 2 to the power of n, at maximum, that number will be 1/2, because n is greater than or equal to 1. So as n increases, 1 over 2 to the power of n will decrease. All right, now I'll give you an example, actually. So let's say we had 1 over 2 to the n, and we let n equal 1. So I'm just going to change this to 1 over 2 to the power of n. It's going to be its own little section here. So you get 1 over 2 to the power of 1. So that's equal to 1/2. What if we had 1 over 2 to the power of 2? Well, that's equal to 1/4. And 1/4 is less than 1/2. And if we had 1 over 2 to the power of 3, we get 1 over 8. And 1/8 is less than 1/4. And by definition, then it is also less than 1/2. All right, so what we can see is as that value for n increases, the overall statement 1 over 2 to the power of n decreases. So that's all that I want to show you there of what we're doing. So the maximum value that this left-hand side could equal in the equation is 1 over 2 to the power of 1, which is 1/2. So what this means is that we can choose a value for c that is greater than or equal to 1 over 2 to the power of 1. So that's 1/2, or any number that's greater than 1/2 for all values of n greater than or equal to 1. All right, so now we can go back here to our original equation. All right, and now instead of us having c here, I'm going to erase that c value and I'm going to plug in 1/2. Okay. So now, is this always true? Well, yes, it is, but let me show you if you don't immediately see it. So now we're going to rewrite the equation again. So we get 4 to the n is less than or equal to 1/2 times 4 to the n times 2 to the n, because that's what is equal to 8 to the power of n for all values of n less or greater than or equal to 1. All right, and now I'm going to divide both sides by 4 to the power of n. So we get 1 is less than or equal to 1/2 times 2 to the power of n for all values of n greater than or equal to 1. And if we write this again, we get 1 is less than or equal to, again, we have 1/2 times 2 to the power of n, so that's 2 to the n minus 1 for all values of n greater than or equal to 1. All right, and now maybe you can see it more clearly, but since the smallest value that n is going to be is 1, 2 to the power of n minus 1 will only increase from 1 to some other arbitrary numbers. It's just going to keep going and increasing in value. So it's going to always be greater than or equal to 1 as n is greater than or equal to 1. So we have proven. I'm going to put over here to the left, I'm going to put 3 dots, which stands for therefore. So therefore our function f of n belongs to or is, so that's the symbol for belongs to, big O of g of n, which implies that 4 to the power of n belongs to or is big O of 8 to the power of n. And that is our answer, guys. So thank you for watching. I hope this video wasn't too confusing. I hope it was helpful. And if you have any questions, please leave them in the comment section below. I will also put more videos on algorithm analysis and big O notation. I'll put some links to those videos in the description. And I'll be sure to put other videos on computer science and discrete math topics in the video as well. And if you found this video helpful, please share it. Maybe it'll be helpful to other people as well. And as always, guys, Don't forget to hit that like button and that subscribe button. And thanks for watching, and I'll see you all in the next video.